Hello, welcome to VM World, and welcome to my session called Show Me the Money, Monetizing 5G and Enterprise Services with VMware. I'm glad to have you here today. I hope this is a great use of your time. My name is Brian Beal, and I work in the Telco and Edge Cloud business unit at VMware, and I'm responsible for strategy and solution innovation, and I also manage our solution architects team. And today, over the next several minutes, I'm going to be sharing a little more about VMware's solutions for private 5G, and specifically why we think the service providers are really well equipped to deliver on private 5G services, and perhaps most importantly, how they can build new revenue and launch services to market around private 5G much more quickly. All right, so with that, let's jump in. All right, so let's talk about really the priorities of the service provider and the telcos that we're hearing when we talk to our customers. And then I'm going to talk about how VMware's Telco Cloud Platform strategy ties in to the needs of the customer. So when we're talking to our customer, really the key priorities that we're hearing about, of course, first and foremost, they're building out their core, their 5G core. We know that is a top priority right now, is getting 5G services to market, both public and private, but getting that public 5G core built as quickly as possible. Next up is extending services to the edge. We also know that edge compute is exploding in popularity. 5G is bringing services closer to the edge. And in order to really kind of deliver on the promise of 5G, things like low latency, for example, and the workloads behind the demand for low latency, we know that we need to extend services out to the edge. Another key priority for the telcos and CSPs is disaggregating the RAN. The RAN is kind of the last great frontier of virtualization, and disaggregating the RAN we know is a top priority. And then last but certainly not least, because it's what we're going to be talking about today, is enabling private 5G and enabling the customer of the service provider, whether it be an enterprise, a smart city, government agency, a hospital, a university, the list goes on, to be able to build their own private 5G solution. And we're going to talk about that as well. And in order to do this and to do all of these effectively, we know that they need a consistent platform. You know, gone are the days of doing all of these deployments in a vertical fashion. Right now, we're building a horizontal infrastructure that can enable all of these services and answers to all of these priorities. And, you know, that consistent platform needs to be consistent from the core to the edge, to the RAN, to the customer premises, and then even extend all the way out into the hyperscalers and the public clouds when appropriate. All right, so now let's talk about how our Telco Cloud Platform strategy helps enable and empower these priorities from our customers. All right, so starting out at the bottom level, the most basic level is our Telco Cloud infrastructure. So this is the infrastructure tools, things like virtualization, app modernization, being able to bring in the best of breed applications from multiple vendors, whether they're in a VM or in a container. Support for multi-cloud, as I mentioned briefly before. How do I deploy my services, not just necessarily on premises and not even necessarily on one public cloud, but into any infrastructure, core, edge, and even multiple public clouds. And then how do I stitch all this together? Networking is very important, especially if I talk about a multi-cloud world or if I'm extending services on premises to edge, to telco core, to public cloud. I need to have a mission-critical network infrastructure to support those services. The digital workspace. We all know that we are living in a whole new world now, and a lot of that will probably stick around for a while. I personally believe that working from home in a virtual workforce is not going to disappear post-COVID. I think it's probably going to stick around for a while. And we need to make sure that we're empowering our employees, our workers, to have access to all of their workspace tools, regardless of where they're at. It can be on a mobile phone, while they're out mobile. It could be in a laptop. It could be in a 5G connected laptop, or it could be in their own home. And then last, but definitely not least, is intrinsic security, making sure the infrastructure itself is secure, but all of the devices connected to the infrastructure are secure as well. That's what we mean by intrinsic security. So we do that by creating a unified, developer-friendly, multi-cloud telco cloud architecture so that carriers can accelerate their business and bring new services to market more quickly. Everybody wins in that model. The customer's happier because, look, customers don't want to wait around for their services to be deployed. They want their private 5G service deployed more quickly. They win, and of course, the service provider wins because they're generating revenue more quickly. And to get there, we know that we need an open environment, disaggregated, vendor agnostic, so that the service provider can build and stitch together that network based on best of breed solutions from many vendors and not just one. No more vendor lock-in for the telco network. All right, so now we're going to drill next level of detail down into each of these solutions provided by VMware. So starting again, the basic fundamental building block of any great network service is the infrastructure. And when we talk about telco cloud infrastructure, we're talking about virtualizing the core of the network, things like your EPC, IMS, 5G core, standalone or non-standalone. Taking that out to the edge, where we might even have more 5G services or private 5G services and other subscriber functions that want to live out in an edge site, such as a central office, and then including the RAN. Very important now that we get into a world of a disaggregated RAN. We provide that consistent infrastructure from core to edge to RAN, and yes, even all the way out to customer premises. As you see in the bottom, we think that this infrastructure, the telco cloud infrastructure, should be able to be deployed in any kind of infrastructure type, not just in a core network, and then I need something else over here and something else over here. No, from public cloud to core network sites to all of your edge network sites and all the way out to customer premises, we give that consistent infrastructure. Then next layer up is telco cloud automation. And this is important. I'm going to be talking about it a little bit more in detail later on in my slides. I'm even going to show some screenshots. But telco cloud automation in the world of private 5G, which is what I'm talking about today, is what allows you to stitch together a multiple different vendors' solutions, their CNFs and VNFs, to deliver that private 5G solution for your customer. So you might have multiple NEPs, you might have multiple other vendors, maybe you have Ericsson and Affirmed or Mavenir, or, you know, we allow you to build out this recipe for private 5G. Let's use a retailer, for example. A retailer has many locations, maybe they have hundreds or thousands of locations that they want to deploy private 5G in. Your solution will probably include a combination of VMs and containers from different vendors for the VNF and CNF and security functions, subscriber functions, RAN functions, and so on. Telco Cloud Automation allows you to build a recipe. Let's call it the Retailer X private 5G store recipe. And allows you to build out all of those solutions. And again, it can be from many different vendors. It can be VMs or containers. It can exist in different types of infrastructure. You may want to deploy some of it in Azure, some of it in AWS. Some of it might be based on OpenStack. Some of it might be based on vCloud Director. We're totally agnostic to that infrastructure type and even what kind of workload it is. And then we allow you to orchestrate and decide all the placement of that, again, in a fully automated fashion. So when you want to turn up a new store, it's a matter of a few clicks through Telco Cloud Automation to instantiate those services and deploy that new retailer's private 5G. You know, gone are the days of weeks of manual involvement trying to deploy a site for a customer. Now you can do it in a matter of minutes. And then wrapping it all up at the top is the Telco Cloud Analytics and Intelligence, or what we call Telco Cloud Operations. This is what your operations teams are going to use to get true end-to-end visibility across their infrastructure, from network function all the way down to the hardware through tools like service assurance, network intelligence, and then AI and ML. And again, visibility from end user device all the way down into the infrastructure we think is really important for your operations teams, especially when you're now delivering private 5G service where you have an enterprise end user customer that you need to monitor as well. So as a telco starts to build out their network platform, here's just some examples of what it could look like. First, you start out with network function virtualization. And to do that, you virtualize your compute, your storage, your network. And if you're using VMs, you'll use a virtual infrastructure manager. And if you're just using containers, there's another option that we use called Tanzu Kubernetes Grid. And this allows you to then deploy whatever you want on top. So again, we're talking now not vertical, we're talking a horizontal layer of virtual infrastructure that can run anything. It can run your IMS, your EPC, your GI-LAN, your vRAN, your SD-WAN services from all of your vendors all on one stack. And you're getting carrier networking, multi-tenancy, which is of course important, and the testing and validation that we do at VMware that guarantees that these network functions are going to work on our platform. And I'll talk about that VNF certification here in another slide coming up, because it's very important and it's what allows our customers to deploy services far more quickly than they used to be able to do. Okay, so I mentioned I'm going to show you a little bit more detail about Telco Cloud Automation, and here's where I'm going to show some screenshots on just how impressive of a tool this is. So first and foremost, it has multi-VIM support. One thing we hear from our customers time after time is that, look, I have legacy applications that I need to support. I can't just, press the reset button and start over. I have applications that that depend on OpenStack APIs. I've got some that I want to deploy in Azure or in AWS or in GCP and Google Cloud. I have some that are native vSphere tenants, or they use vCloud Director as a VIM. Just a few examples. Well, that's great, because with Telco Cloud Automation, you can build out a complete solution from many vendors regardless of the VIM, and even regardless of the underlying infrastructure that you'd like to deploy in. And next up is consumption. So once you get something built out, you can actually go and get a great visibility into your dashboard here on how much CPU, memory, and storage you're using across all these different infrastructure types. It's probably small here, but I've shown an example of an EPC. There's a RAN use case, IMS, AMF from different vendors that are all deployed out in multiple infrastructure types. We have some being deployed in private cloud. We have some that are being deployed in public cloud. Here I get a complete end-to-end dashboard of all my utilization and consumption, regardless of the underlying infrastructure types. And this is also now where I can start to get into my network services catalog as well. That takes me to modeling. So as you stitch together a complex network from core to edge to customer premises to public cloud, as you can imagine, the network becomes really, really important. And with Telco Cloud Automation, you can actually do drag and drop of VNFs, and it'll automatically design these network services. And this uses open source or open standards tools like ETSI, TMF, so tools that we're already all familiar with, we're leveraging here to stitch together these networks and model it out. And then once we've done that, once we've kind of picked out our VNFs and CNFs, we've modeled it, now we can orchestrate it. So this is where we're actually now connecting the network together, building out these services, instantiating the services, and deploying our new private 5G solution. And the great thing is this also ties in to the service assurance tools, OSS systems. So the things that you're already using as a telco or as a service provider to get visibility into your network end to end, to do troubleshooting, the tools your ops team uses, and of course the things that you use for billing, this will tie in to those tools as well. And that is a very high level overview of Telco Cloud Automation. And if it's interesting to you, I encourage you, there's other sessions on Telco Cloud Automation, or of course, reach out to VMware anytime. We can give you a deep dive in Telco Cloud Automation. It's a really incredible new tool. Okay, so if you're going to deploy something more quickly, this is another critical advantage that we have at VMware, which is our Telco Cloud Infrastructure Certification Program. This is where we actually run our own lab, and we work with partners, some of which are listed here, to bring in and onboard their VNFs and CNFs on our Telco Cloud Infrastructure platform to test them and ensure that they're going to work. I like to say, none of my customers want to be the guinea pig. They don't, and gone are the days of having to do months and months of testing on different drivers and, different versions of different products. We take on that workload, and we do that for all the major NEPs and ISVs. We have over 155 different VNFs and CNFs certified as of today, and that number grows daily, and it's a public list representing over 35 different partner companies. And it ranges across the gambit from 5G core to EPC, IMS, security functions, SD-WAN, you name it. If it's a use case that a telco needs to deliver a service, we're willing to take it in, bring it on board, and do that testing and certification in our lab. It's just something that greatly accelerates time to market for our customers. It's one of the things that we consistently hear from our customers that allows them and enables them to launch services more quickly, taking it down from many months in some cases to a few weeks to launch a new service because we take on the certification process. Now, the Telco Cloud Infrastructure Certification has been going on since before I joined, over 4 years ago. So we've been doing this now for over 5 years, and we're now extending what we've learned in certifying for the infrastructure layer to now also include the automation in our Telco Cloud Automation Suite. So we're now bringing in partners and certifying them for both. So we have over the 155 that I mentioned for Telco Cloud Infrastructure, and now we're bringing in and adding more and more by the day certifications for Telco Cloud Automation. And you see there the certification reference. We use ETSI compliance interfaces to do the certification. Reason why we do it is we want to make sure that not only will the VNFs and CNFs run on our infrastructure, but now we want to make sure that we can also automate and stitch together that multi-vendor solution that I mentioned in the previous slides. And then I give you a few examples of the test scope here. I won't read all these off to you, but again, I encourage you, this is a partial list. If this is of interest, again, reach out to us. We'd love to show you more about our certification program. And it is really one of the things I think that we do that's really special. Okay, so I mentioned, of course, no customer likes to be the guinea pig. Well, good news is this business unit, now that we've been around 5+ years, we have a phenomenal footprint of customers spanning the globe. Over 80 telcos and service providers using us to virtualize their network functions. They're running their EPC, IMS, VoLTE, 5G, doing call processing and running the core of their network all day, every day. And representing over 800 million subscribers now running on this platform. And again, I mentioned over 150 plus certified VNFs. And one of the things that I'm really proud of here is that this customer list represents some of the largest telcos in the world with hundreds of millions of subscribers, but we also have customers that are very small telcos that have, single-digit millions or even less than 1 million subscribers. And I think that's important because it shows the economics of virtualizing your network with VMware makes sense whether you're the smallest carrier or the largest or anywhere in between. The economics make sense. We help you deliver those services more quickly to your customers in a repeatable fashion. That I think is something that's really important. It's not just for the biggest of the big, it's the big, the medium, and the small. Everybody benefits. So in addition to our NFV footprint, we have over 100 telcos and CSPs using our VeloCloud solution for their SD-WAN services. And then we have over 100 plus using VMware to power their IaaS or their public cloud services. So that's a little bit more on our footprint today, and it's growing rapidly. And then last but not least, over 3 million VMs deployed today in telcos and SPs. Okay, so now I'm going to talk a little bit about our solution strategy, and specifically our solution strategy from core, the telco core, to edge, to access, to the end user, the enterprise. So if I start here with the core, the telco cloud, the telco core cloud has been being transformed now for a few years. NFV is now several years old, and most telcos started down that journey. But boy, 5G is really accelerating the transformation. Our CEO, Pat, made a quote a few years ago that I really loved, and it's coming true, where he said, we think there will be 2 types of 5G networks, those that are virtualized and those that will fail. And I love that. And boy, we're seeing that come true today because 5G really puts some new demands on the infrastructure from core to edge. And 5G really needs distributed computing because most 5G applications, and one of the key benefits of 5G is low latency. And you kind of need distributed computing to really reach the benefits of those low latency use cases. And then as I extend that out to the network edge is now starting to look like a mini cloud. It's becoming far more intelligent. It can run a myriad of use cases from IoT applications at the edge. Of course, we're running now network functions at the edge, especially with private 5G, and we're even running applications at the edge. Increasingly, we're hearing from our customers that they want to help enterprises or governments or whoever the end user customer might be start to move workloads off of on-premises and into this network edge. And they might want to do it for burst capacity. They might want to do it just because they don't want any more infrastructure on the customer site. There's a myriad of reasons, but point being, once you get a common infrastructure from core to edge to customer premises to public cloud, those workloads become really mobile, and they can go and they can move based on where they need to go. And then, of course, as I start to move out to the enterprise edge, you see other use cases here. Just a few examples, but these are ones that we're seeing most of the demand for private 5G are things like branch offices. I mentioned retail, certainly mining or any type of enterprise use case that's out in a really remote area. Connectivity is sparse. As you can imagine, private 5G is big there. Industrial applications and smart factories is driving a lot of demand. Smart cities, venues, just a few examples of where private 5G is driving demand. And then last but not least, the public cloud. And we have some customers that are saying, oh man, I want to consume as much public cloud resources as I can to power my network functions. We have others that say they want to use it as little as possible, and then we have everybody in between. Point being, we want to give absolute flexibility. I like to say that workloads want to run where they want to run, meaning some workloads just need to be really low latency, really close to the end user. Things like virtual desktops are one example, or factory automation, things like that. They need to be close to the end user. But other applications don't need to be really close to the end user. So by building this flexible platform from edge to core to public cloud, you can put that workload wherever it needs to live. So as we start to build out, a common thing we like to talk about is, okay, what are the real use cases? And what really needs to start to live out at the edge, and it needs to live close to the customer. And I put just a few examples here. Factory automation is one that really requires what I consider to be ultra low latency, and can really start to take advantage of the 3GPP standard around ultra high reliability and low latency. You can see, some factory automation use cases actually need sub 1 millisecond latency. And even on the high end, 12 milliseconds. I mean, that's still a pretty low number. So this is an example of a use case you're probably going to want to run either on premises or really out pretty far at the edge. But honestly, factory automation, most of that is going to want to run on premises. So that private 5G deployment that the telco would provide would probably take advantage of some on-premises applications for things like the RAN and some of these factory automation tools that would be used. And then, of course, we go on from there. Everything from augmented reality, vehicle to vehicle is really common now and coming up quite a bit on how we can start to leverage edge compute in 5G sites to connect vehicles together to do traffic flow modeling, crash prevention, things like that. And then a few more use cases here that I've mentioned. Again, not a complete list. Just I want to show some real world examples of how you can use the edge to deliver really low latency to solve some of these problems listed here. All right, so now let's talk about private connectivity in more detail. So there's some real market drivers, and boy, they sure are accelerating now in this kind of crazy world we live in. But really the industry now, whether it's manufacturing, mining, retail, healthcare, those are just a few examples. Certainly the governments are also starting to get into private 5G as well. They really they want a new type of network. They want a network that can give a different standard, a different QoS depending on the use case, because some devices need that really low latency, high reliability all the time, but others don't. IoT devices might need, a different slice that has a different quality of service. And then of course, these industrial applications or these end user customers are expecting really secure connectivity. Many of these customers want their devices off of public networks in some cases, and that's certainly another great example for private 5G. And then, of course, we've just got this massive growth of connected devices. If I go back to industrial automation as one of those examples, virtually every device being put on a factory floor right now is a connected device. Some of those, like I mentioned, are mission critical devices that need that ultra high reliability slice of the network to work all the time to keep the factory moving. And some of them are just providing some basic telemetry and can go on to an IoT slice. But the point being, we need to be able to divvy up that workload depending on what that device needs. And we know that the kind of mobile, old school 4G networks really can't handle that today. So this private connectivity, again, whether LTE or 5G, we know that we're going to get better coverage in location. We're going to be able to get a better QoS model, and then, of course, build in security. And just a few use cases mentioned here for more examples. All right. So a question that comes up, why do I need a service provider to deploy private 5G? You know, can I go get some unlicensed spectrum and I'll go build it myself? And, you know, there were some instances of this to some customers that tried this, and will continue to try it. But we really, truly believe that for the vast majority of end user private 5G customers, whether they be private, public, whether they be a government or an enterprise, they really are going to look to the service providers to deliver this. Mainly because if the enterprise tries to do it themselves, it's going to be expensive and it's going to take a long time. It's just not the core competency of most enterprises to start to build, deploy, and manage 5G networks. We think that a service provider delivered a private 5G that's turnkey gives a much quicker time to market. It's more repeatable. The service provider can get it installed probably quicker than an enterprise can. They've already stitched the network functions together, and it's probably going to be lower cost. This is really what we believe. So we think that the service providers out there are going to be able to deliver this and give a better service to the customer. Again, customer is going to be happier because they're going to have the private 5G services that they need, you know, in a matter of days, rather than months of trying to stitch this all together themselves. And I also wanted to show some examples, some kind of more niche use cases for what private cellular services can look like. One of the more interesting ones that we've seen come up is this idea of a nomadic edge or a mobile edge. We're seeing this for first responders, military, the use case where you actually might need to put a private 5G in a backpack or in a vehicle and take it out to a really remote site for, again, maybe a first responder use case, maybe a missing person or disaster of some type, where you need to get out to this remote site. And, you know, geography, maybe 20 square miles, connectivity, probably not super latency sensitive in this use case, and then not a lot of users, maybe less than 500 total users attached to this. And some services, video, for example, they might be out flying a drone around the area to survey the area, and they want to stream that video down to first responders on the field. That's certainly one use case. Voice connectivity out in these ultra rural or ultra remote locations are going to be challenging. You would probably use it for voice as well. And then location services. And you could use shared or unlicensed spectrum for this particular use case. So that one's kind of cool. That one's unique and I think really interesting. The next one is pretty common, enterprise edge, and this is what a lot of people think of when they think of private 5G. This is the mine or the hospital or the retailer that wants to get a private 5G service on site. Now, there really are kind of two models of doing this. There's the do it all on premises model, and then there's the do as little as you have to on premises and then do the rest behind the service provider firewall, so to speak. Some examples, smart factory, I mentioned mines, hospitals, things like that. And I think what will really determine whether you do this completely on premise or you start to do it more on the telco, which is the example on the right, is really kind of how many users and things like that you're gonna, and how mission critical the connectivity is. I mentioned in that factory automation use case, if you have factory equipment, smart factory equipment that need this super low latency, yeah, that's probably gonna be enterprise edge. You're probably gonna be deploying most of the private 5G services on the premises. And in this example, you know, a square mile, probably less, unless it's a mine site. These are smaller if you think of your average retail or your average factory, and probably less than 10,000 total devices attached in this use case. And then on the far right is the telco edge. Now we're starting to talk about really deploying private 5G services at massive scale, where the telco is going to take on and provide a lot of the heavy lift of the private 5G infrastructure in their own edge and in their own core. So think of a smart city, for example. Think of even large universities where you're now talking up to, you know, maybe 100+ square miles of coverage. You're talking about hundreds of thousands of devices, millions of devices attached, and a litany of use cases. Everything from location, video, and voice, but now even MEC services, CDN, video, caching, and things like that. And this will be, since it's telco edge, now we're talking licensed spectrum. This is the service that a telco could go and take to a smart city and deploy it and manage it for them, using primarily licensed spectrum. Okay, so let's talk about, you know, just this is a conceptual architecture. So if you think of the private zone managed by this highly distributed edge deployment of these 5G private zones managed by the service provider, you're going to have, of course, the physical infrastructure. And you're probably even going to start to virtualize more of this than just the CPU. And that's something VMware is working on, you know, quite rapidly, is how we start to virtualize different things like the GPU, the CPU, of course, running workloads on NIC, doing NIC offloads, FPGA, things like that. VMware Telco Cloud, providing the virtualized infrastructure to run these functions. And then you've got your actual services, your IMS, your vRAN, UPF, and CPF. Now you're starting to get into user plane and control plane functions. And then you have the management network, and then you have third parties that may be doing things like SIM management. One thing that we hear from enterprises pretty frequently is they don't want to be in the world of trying to manage devices and whitelisting SIMs and managing phones or IoT devices. So that's probably a third party. Maybe some SPs want to do it, but that's certainly open to a third party. And then you have the service provider operations teams actually now managing this network, doing service assurance, doing the operations management, doing the orchestration, things like that. But this is at a high level what the solution could look like. So, you know, where's the value, you know, and who wins in this model? And we really think that, again, there's this idea of shared infrastructure for administrative domains. This would work for the enterprise edge, but now you also have dedicated infrastructure. This is where the telco edge comes into play. And you could get an idea of the different type of use cases deployed on each. What's important to note is that on the telco edge stack, the VMware stack, we really are agnostic whether it's going to be IaaS or CaaS, VMs or containers. And this is important because we really think that for the foreseeable future, this environment is going to be heterogeneous. We're going to need to support VMs and containers existing side by side. So you see that on both sides here, whether shared infrastructure or dedicated. You know, on dedicated infrastructure, now you've got out at the telco edge, you're going to have 5G and 4G control plane, user plane functions. Then you're going to start to see maybe MEC or CDN. Again, you're getting that consistent infrastructure from VMware at the bottom, regardless of the infrastructure type and regardless of whether it's a container or a VM. Very important, because we know that containers, despite we know that they're the future, we also know there's going to be a transition. And we know that customers don't want to have to stand up a VNF environment over here and a CNF environment over here. We want it to be the same regardless of infrastructure type or the use case. And then just digging down, next level of detail, private LTE, 5G deployment, you start to see here there's this multi-tenant model of multi-tenant RAN and IMS, the vRAN out to the 5G user plane functions. And then if you look at the bottom, VMware Telco Cloud providing that underlying infrastructure across all the multi-tenant resources, and then as well as the control plane resources, backed up by Telco Cloud operations and automation, providing all the benefits I talked about before. And again, whether they sit at the enterprise edge. So you see at the enterprise edge, we see a lot of 5G user plane functions and some control plane functions out at the enterprise edge, the vRAN, IMS. As we start to move into the edge network, now we're starting to see some disaggregation. We're starting to see, maybe just the IMS is there, but we're probably still keeping vRAN on the enterprise edge site. Or we can go into that full multi-tenant vRAN, IMS, the user plane and control plane functions all sitting in the edge, right? It's really up to the use case. It's up to the service provider, but we provide the flexibility regardless of the 5G deployment model that makes sense for that customer or that use case. All right. So that's a lot to cover in less than 45 minutes. I hope that, the theme that you learned and heard throughout the session today was that VMware is not only heavily invested and committed to the future of 5G, but also the future of private 5G. And we see our service providers and our telco partners as critical components in that. I encourage you, reach out to anyone at VMware if you want more information. Our team would love to talk to you more about this. I encourage you also, please fill out your survey. Let us know if this session today was useful for you. That's very important. It helps us craft content. We want it to be useful for you, so that's very important. And with that, I'll close. I'll thank you all for this attending this virtual VMworld this year. I hope we all get to see each other again in 2021, and I hope you're all staying safe, healthy, and hopefully I get to meet some of you live here in the not too distant future. Thank you.